In this video, we're going to talk about Gaussian elimination method. How to use the Gaussian elimination method to solve a system of equations. Now, we have a system of three equations here that we're going to solve using the Gaussian elimination method. Okay, so this is how we solve it. First of all, I want to write these equations in the form of a matrix. Look at it. I have three variables, x1, x2, x3. So the coefficient of x1 here, 1, 3, 4, will form the first column, 1, 3, 4. The coefficient of x2 here, 2, minus 1, minus 6, will form the second column, 2, minus 1, minus 6. And the coefficient of x3, 3, 2, 4, minus 4, will form the last column, 3, 2, minus 4. And then I'll multiply this matrix by x1, x2, and x3. The product of this matrix is equal to the right hand side, 5, 8, minus 2. I've written the system of equations in the form of a matrix. Okay, so we now form what we call the augmented matrix. The augmented matrix is this. This matrix, I'll write it down. 1, 3, 4, 2, minus 1, minus 6, 3, 2, minus 4. And then I'll use a vertical line to separate this matrix or these entries from the right hand side, 5, 8, minus 2. This is the augmented matrix. So what we'll now do is this. We are going to perform some operations here. The goal is to make all these elements on the principal diagonal to be 1 and all other elements below it, all other numbers below it to be 0. That means we are going to form an upper triangular matrix. You know, in an upper triangular matrix, all the elements below the principal diagonals are 0. So that's the goal here. All the numbers on the principal diagonal will make them 1, while all other numbers below the principal diagonal will be made 0. That's what we are going to do now. So we'll perform some row operation to arrive at the goal. So just watch to the end and see how it's going to be done. The first element here, the first number here is already 1, so we have no problem with that. So let's change this number to 0. We have 2 here, let's make it 0. So see what we're going to do. To make it 0, since it's 3 here, I can multiply if I multiply this number by 3, this number here by 3, I'll get 3. 3 minus 3 is 0. So I can say multiply row 1 by 3, then subtract row 2 from it. Or multiply row 1 by 3, then subtract it from row 2. What I get, I'll place it in row 2. Look at it. If I multiply this by 3, 3 minus 3 is 0. I'll put 0 here. Multiply this by 3. 3 times 2 is 6, right? 6 minus 1. That's 6 plus 1. That will give me 7. Multiply this by 3, that's 9. 9 minus 2 is 7, right? Multiply this by 3, that's 15. 15 minus 8 is still 7. Well, I'll put it 7 here. So all other entries remain the same. This is 1, 2, 3, 5, 4, minus 6, minus 4, minus 2. That's it. So we have succeeded in changing this number here to 0. This is what we have. So we'll now change this one to 0. You know, this is the principal diagonal. So numbers below it will be 0. We change this one to 0. To make this one 0, so what we're going to do, if I multiply 0 by 4, I'll get 0. And 0 minus 4 is minus 4. And that will not solve the problem. I need this one to be 0. So if I multiply this by 4, for example, 4 minus 4 is 0. Good. So I'll multiply row 1 by 4, subtract row 2 from it, so that this one can be 0. And this is what we'll now get. Multiply this by 4 is 4. 4 minus 4 is 0. Multiply this by 4, that's 8. 8 minus 6, that's 14. That's 8 plus 6, 14. You get it? I'm multiplying row 1, this is row 1 by 4, and then subtracting row 3 from it. 4 times 1 is 4, minus 4 is 0. 4 times 2 is 8. 8 minus 6, because there's a minus here, so we have 2 minuses. That will be 14. 4 times 3 is 12. 12 minus 4, that's 12 plus 4, and 12 plus 4 is 16. 4 times 5 is 20. 20 minus 2, that's 22. All other entries remain. 0, 7, 7, 7, 1, 2, 3, 5. Alright, we have to make this last one a 0. You get it? Yes, 14. We have to make it a 0 now. So we can easily make it 0 by, since it's 14, see something. 0 minus 0 is 0. If I multiply 0 by anything, it's still going to give me 0. So if I subtract 0 from 0 is 0. But if I should use this row 1, if I say, okay, if I multiply this 2 by 7, it will give me 14, right? 14 minus 14 is 0. But if I multiply this 1 by 7, it becomes 7. 7 minus 0 is now 7. You see that this one will now turn back to 7. So we don't need that. I'll just eliminate this. I'll just leave this row alone. Since this one will give me 0 minus 0 is always 0. Even if I multiply it by anything, I'll make use of this row 2. So that if I multiply 7 by 2, that will be 14. 14 minus 14 is 0. It does not affect these two zeros that we have already. 0 times 2 is 0. 0 minus 0 is 0. So we're on point. So we just multiply this row 2 by 2 and then subtract row 3 from it. 2 times 0 is 0. 0 minus 0 is 0. Put it there. 2 times 7 is 14. 14 minus 14 is 0. Good. 2 times 7 is 14. 14 minus 16 is minus 2, right? 2 times 7 is 14. 14 minus 22 is, alright, so all other entries remain the same. 0, 7, 7, 7, 1, 2, 3, and 5. The goal is to make the elements on the principal diagonals to be 1 and all other numbers below it to be 0. So this is already 1. We have to make this one 1. Okay? And we have to make this 1 also. To make this one 1, what we'll do is divide everything here by 7. Because 7 divided by 7 is 1. This first row will remain as it is. Alright, since this one is already 1. Then for the second row, if we divide 0 by 7, we'll get 0. Divide 7 by 7, we'll get 1. 7 divided by 7 again, we'll get 1. And 7 divided by 7 is 1. To make this minus 2 1, we have to divide by minus 2. Alright, divide this row by minus 2. 0 divided by minus 2 is 0. 0 divided by minus 2 again is 0. Minus 2 divided by minus 2 is 1. Minus 8 here divided by minus 2 is 4. Alright, so this is what we have now. We are going to make back substitution. 1, 2, 3. This is the coefficient of x1, the coefficient of x2, the coefficient of x3, and this is what we have at the right hand side. So this will be 1x1, which is x1, plus 2x2 plus 3x3 equal to 5. That's what this is. Then for this, since this one is 0, it means that x1, the coefficient of x1 here is 0, and that means it becomes 0. So there will be no x1 here. We now have 1x2, which is x2, plus 1x3, which is x3, equal to 1. Here, the coefficient of x1 is 0, the coefficient of x2 is also 0. So we only have x3 here. 0, 0, that will give 0. You get it? So we have just s3 equal to 4. We have gotten x3 already easily. So x3 is equal to 4. So let's now get x1 and x2. Now, since s3 is already equal to 4, if I put 4 here into this equation, this second one, I'll have x2 is equal to 1. s3 will cross and turn to a minus, which is 4. And that's what? Minus 3. So s2 is already minus 3. What will now be x1? x1 from this equation 1 is 5 minus 2x2 minus 3s3. Remember that x2 is already minus 3, right? So minus 2 times minus 3 is plus 6. x3 is 4. Minus 3 times 4 is minus 12. You get it? So 5 plus 6 is 11. 11 minus 12 is minus 1. So s1 is equal to minus 1. So these are the solutions. s3 equal to 4, s1 equal to minus 1, and s2 equals to minus 3. Let's solve this system of equations using Gaussian Elimination Method. The second question now. We can go straight to the augmented matrix. This is it. The coefficient of x, 2 minus 3 minus 2. 2 minus 3 minus 2. The coefficient of y, plus 1 minus 1 plus 1. That's 1 minus 1, 1. And the coefficient of z, minus 1, 2, 2. Minus 1, 2, 2. 8 minus 11 minus 3. What we are going to do now is to make all these numbers on the principal diagonal to be 1 and all numbers below the principal diagonal 0. Okay, here we have 2. I can easily make this 2 to be 1. That's not a problem. Let me focus on the other numbers to make them 0. Minus 3, minus 2, and 1. Now, how do I make minus 3 0? If I multiply this 2 that is here by 3 all over 2, what will I get? I'll get 3. Okay, so I'll get 3. I can easily say 3 plus minus 3. This minus 3 is what I have here. This 3 is what I got when I multiplied 2 by 3 over 2. If I subtract minus 3 from 3, I'll get 0. So I'm trying to look for a way to make this 2 to be 3. so that I can say 3 plus minus 3, which is 3 minus 3, and that will give me 0. And the only way to make this number 3 is to multiply it by what? 3 over 2. And that's what we did. 2 times 3 over 2 is 3. So if I add it to this minus 3, I will get 0. So what I'm going to do is to multiply every element in this row 1 by 3 over 2 and add corresponding numbers in row 2 to each of them. See it. If I multiply this by 3 over 2, I'll get 3, right? So if I add 3 to minus 3, that will be 0. So I'll put my 0 here. If I multiply this by 3 over 2, that's 1 times 3 over 2. I will get 3 over 2. 3 all over 2. What is here? Minus 1. If I add minus 1 to it, and this is actually 3 over 2 minus 1. And that will be 3 minus 2 all over 2, which is 1 over 2. So have 1 over 2 here. And for this, multiply this by 3 over 2. That will be minus 3 all over 2, right? Then we'll add this one to it, plus 2. So what will it be? This is minus 3 plus 4 all over 2. 2 times 2 is 4. Using LCM. So 4 minus 3 is 1. So we have 1 over 2. Alright, so here I have 1 all over 2. I'll do same for this. Multiply this by 3 over 2. That's 8 times 3 all over 2. That will give me 12. Because 2 here is 1, 2 here is 4. 4 times 3 is 12. 12. Add minus 11 to it. So 12 plus minus 11. That's 12 minus 11 is 1. So here we have 1. So this is 3 minus 2, 1, 2, minus 3. And then we have 2, 1, minus 1, 8. The goal is to make this, and this to be 0. We are going to deal with this one later to make it 1. It's going to be easy, so let's not bother about it too much. 0, 0, 0. That's the focus for now. Now let's make this 0. Okay, you can easily do that without performing too much operation. Here is 2 and here is minus 2. How do I operate these two numbers to obtain 0? 2 plus minus 2 is 0. Here is already minus 2, so if I add 2 to it, I'll get 0. So what I'll do here is to add corresponding elements in row 1 and row 3. Because I want this one to be 0. Here will be 0. Because minus 2 plus 2 is 0. If I add 1 and 1, 1 plus 1 is going to be 2. 2 plus minus 1, 2 plus minus 1, which means 2 minus 1 is 1. Is 1. Here we have minus 3, right? Minus 3 plus 8. Minus 3 plus 8, that's 8 minus 3, which is 5. All other entries remain the same. This is 2, 0, 1, 1 half, minus 1, 1 half, 1, 8. So let's now make this one a 0. Okay. If I want to get 0 here, I must not operate this row with this one. Okay, this is row 1, this is row 2, this is row 3. To get a 0 here, I must not operate this and this. If not, this one will not be 0 anymore. So I'm going to make use of row 3 and row 2. Okay, the only way to get 0 here, to make this 2 0, is to subtract 2 from it. Alright, if I say 2 minus 2, this is 2. If I subtract another 2 from it, that will be 0. But if I say 2, if I add minus 2 to it, that will also give me what? 0. So if I'm subtracting 2 from it, it means that I'll have to make this number here to be 2. So that when I say 2 minus 2, this will be 0. I hope you get what I'm saying. So to make this one 2, this is already half. That's 1 over 2. I'll multiply it by 4. Yes, because 4 divided by 4 times 1 is 4. 4 over 2 is 2. We are going to multiply each element here by 4. Okay, and then subtract the corresponding element in row 3 from the result to obtain a new row 3, so that this one must be 0. You get the point now? So this is what we have. If I multiply 0 by 4, this is 0, I will get 0. 0 minus 0 is 0. If I multiply 1 over 2 by 4, that's 2, we said it is 2. 2 minus 2 is 0. Multiply this by 4 is still 2. 2 minus 1 is 1. Multiply this by 4. That will be 4 times 1, 4. 4 minus 5 is minus 1. All other entries remain. 0, 1 half, 1 half. Oh, this is supposed to be here. Pardon, this is 0. This is 1. This is 1 over 2. This is 1. I hope you get it. This is 2, 1, minus 1, 8. So let's make all elements along the principal diagonal to be 1. This is already 1. Okay, so let's make this and this 1. It is very easy. We can do that in one step. To make this number 1, I'll divide everything here by 2, because 2 divided by 2 is 1. So if I make this, if I divide this by 2, 2 divided by 2 is 1, so I'm having 1 here. 1 divided by 2 is 1 half. That's 1 over 2. And the same thing here, I'll have minus 1 over 2, while I'll be having 4 at this right hand side, because 8 divided by 2 is 4. Since I'm going to make this one 1, and I'm having a fraction 1 over 2, to make it 1, just multiply by 2 over 1. It will give me 1. So what I'll do is to multiply everything here. You get it? Everything here by 2 over 1, which is 2. 2 times 0 is 0. 2 times 1 over 2 is 1. And this will still give me 1. And having 2 here, because 2 times 1 is 2. And this row will remain the same. 0, 0, 1, negative 1. I've gotten what I want. So I can easily determine x, y, and z. So I'm going to write this augmented matrix, this matrix now, in the form of a system of equations. Look at it. These numbers on this column are coefficient of x. These ones are coefficient of y. These ones are coefficient of z. While these are the right hand side of the equations. The coefficient of x here is 1, so we have 1. Of y is 1 over 2. We have 1 over 2, which is positive. Of z, it is minus 1 over 2, and that's what we have here. And this is equal to 4. For x here it is 0. That means there will be no x here, because 0x is 0. So that one's out. Then we have 1y, which is y, plus 1z, which is z, equal to 2. 0, 0. That means there will be no x, there will be no y. Because 0 times x, 0. 0 times y is 0. So I'm just having 1z, that's z, which is equal to minus 1. You can see that z has come out of the equation already. Z is equal to minus 1. So z is already out of the equation. I now need to determine the value of x and y. If I place minus 1 for z in equation 2 here, means that y minus 1 is equal to 2, right? Yes. That's, I'm writing minus 1 for z here. And so if I collect like terms, minus 1 will cross to this side and turn to a plus 1. So I'm having y equal to 2 plus 1. That means y is equal to 3. So y is 3, z is minus 1. What is x? What we'll do now to get x is to plug in the values of y and z into the first equation. We are having x plus half into y, where y is 3. That will be 3 over 2. You get it? 1 over 2 times 3 is 3 over 2. Minus z is minus 1. Of course, minus half times minus 1 will be plus half, plus 1 over 2 equals to 4. 3 over 2 plus 1 over 2 is actually 2. They have the same denominator, so add their numerators. 3 plus 1 is 4, and divided by the common denominator, 4 over 2. That will give me 2. So I'm having this x plus 2 equal to 4. And if we collect like terms, 2 will cross and turn to a minus. It means that s is equal to 4 minus 2, and that is 2. These are the values of x, y, and z that satisfy the system of equations that we have above. This is how to do Gaussian elimination method. Okay, I hope you enjoyed the video. Keep supporting by subscribing to this channel. Like the video and share it with your friends and your course mates. I'll see you in the next one.